This problem, we're going to look at, this was a test problem. It looks very similar to the one, I don't think it was my year, but we had one very much like this. So let's take a look at it. Some of the parts are already in the correct form, some are not. So hopefully, if you don't understand bode plots by the time we're done with this, hopefully you will. Because they're not that bad. And y'all don't have to do phase.
Your other video also explained it pretty well.
Oh, good. So go to my other video, because this one's not very good. Because I'm too tired. All right. So we need to get these all in the right form. The right form means that the constant term is 1. So we'll get all the constants together after we have factored it. We'll get all our constants after we've taken the things out of the ones that we need to. So we can leave the 2 times 10 to the 5th for now. The 1 plus j omega over 400 is fine because the constant term is 1. For this next one, I need to take out an 0.5. So I'm dividing by a half. And if you have problems, if I say 8 divided by a half and you say 4, then just use your calculator. Because dividing by a half means multiplying by 2, and what we're multiplying by 2 is in the denominator, so we are actually in fact going to be dividing it by 2. But if you're not entirely sure, then just take whatever your number is, 1 over 1600, and divide it by whatever it is that you're factoring out. So,
no, my brain was always like divide by 2 for decimals.
Yeah. So when we divide 1 over 1600 by 0.5, we end up with j omega over 800. Over. And then this gives me 1 plus j omega over 50 squared. That one is fine because it has a 1. For this next one, I'll need to factor out 1,000. So that will give me 1 plus. Now if I am dividing by 1,000, then I need to divide that by 1,000. So that'll move the decimal 3 places. So that would be 3.125 times 10 to the negative 4. Negative 4 j omega. And then this one, I'll just subtract 3 from the exponent. So it'll be 2.44 times 10 to the negative 8 omega squared. And again, if you don't like doing that arithmetic, just divide. So then I'll take my constants, all of my constants, and I have 2 times 10 to the 5th, and I have a 0.5, and that's over 1,000. So that's my constant term. It should be 0.5 squared, thank you. Because that was coming out of something that was, and I forgot my square here. So I don't know if that makes it better or worse that I forgot all of my squares. So yeah, it should be squared. Times 1 plus j omega over 400 times 1 plus j omega over 800, and these are both supposed to be squared. Now, in the denominator, what I need to do is I need to figure out what this is as j omega over omega c squared. So I know that negative 2.44 times 10 to the negative 8 has to equal, well, plus 2.44 over 10 to the negative 8 has to equal 1 over omega c squared. So omega c has to equal 1 over the square root of 2.44 times 10 to the negative 8. And somebody is going to be so kind as to tell me what that is.
I don't trust that first.
Okay.
That's not what I because I squared
6,400.
Somebody learned that. Maybe tomorrow.
So then I can write that quadratic term. Well, I can write the whole thing. So first, let's get 2 times 10 to the 5th times 0.5 squared divided by 1,000. So that would be 200 times a fourth, which would be 50. Can someone verify that that's 50? That this is 50? Yes.
Yes.
And I hope y'all are all very impressed. J omega over 400 squared, 1 plus j omega over 800 squared over 1 plus 3.125 times 10 to the negative 4th j omega plus j omega over 6401 squared. So the only thing this doesn't have that you do need to know how to do is a pole or a zero through the origin. And everything here is squared. So if this is the first time you've done one of these, you might get the impression that your slopes are all 40. But when things aren't squared, the slope is 20. So what we have is we have a constant. That is 50. Things in the numerator are zeros. So we have a simple zero with omega c equal to 400. And n equals 2. That's the exponent. We have a simple zero with omega c equal to 800. With n equals 2. So what this means is if you have a zero, then that gives you a slope. A zero has a slope of n times positive 20. So this will give me a slope of positive 40. And n times positive 20, this will give me a slope of positive 40. And then I have a quadratic zero. Quadratic pole. In the denominator you have poles. A quadratic pole with corner frequency 6401. Poles have negative slope, and since it's quadratic, it's going to be negative 40. If it was a simple pole, it would be negative 20 times n. Did I lose it?
There's a 1 plus J50 that's multiplied by the.
There was a poll in the original. It was already.
1 plus J. Okay, so we had it was height is where it went. Is 1 over J omega 1 plus J omega over 50 squared. So we have a simple pole with a corner frequency of 50. And
and
poles have a slope of negative 20 times n. And its n is also 2, so it also has a slope of negative 40. All right, so we've got all of those things. So now we're ready to, the next thing we have to do is take 20 log of 50, and that's going to be about 37. Let's see. You have to press the natural log button.
Oh, yeah.
33?
33?
33?
34.
34.
20 log 50.
20 log
20 log 50.
About 34.
Yeah, 34.
All right. So the first thing we do is we take that constant, which was O.
Yeah, that's why I was like,
We're going to
little
change
confused.
these because I just got this. I didn't work it out. We're going to change. We're going to multiply all these by 2.
that would not work.
So we'll make these 20, 40, 60, negative 20, negative 40, negative 60. Okay, so our constant term was at 34. So that'll be right here. So you do that first. Now we don't have anything that goes through the origin. If we did, we would have to draw those first. And if you want to see how to do that, go take a look at my other video because I do that in the other one. So it's probably a video that says bode.
Yeah.
Okay. Then we have a 0 with corner frequency. What?
400? Simple zero?
Simple zero.
At 400.
At 400. Okay. So at 400, here's 100. Here's 200, 300, 400. So it's a simple zero. So that means it's 0 until it gets to 400. And then because it was ordered 2, the slope is 40. That means I go over 1. And by going over 1, I mean go over to the same type of vertical line in the next decade. And then go up 40. And I get that one. Okay, then what's the next zero? Or is there not another zero?
800.
800. So 800 is right here. So I have 0 until I get to 800. And then it'll have a slope of 40, which means it's parallel to this. So I'm not going to go over and count. I just know it's going to be parallel. Then I have a simple pole. So a simple pole is 0 until you get to its corner frequency, which was 50. Okay, so here's 10, 20, 30, 40, 50. So it's 0 until I get to 50. And then we have a slope of negative 40. So I'll go down 40. And that would be that one. And then I have a quadratic pole with corner frequency 6,000. So here's 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. And so I'll go over here. And then it also, because it's quadratic, has a slope of negative 40. So it'll be right there. Now, to get the composite, you start where you add up all the numbers you have here, which here is 34, and then from here on we're going to be adding slopes. The slope is 0 until I get to 3. And then I have a slope of negative 40 until I get to, what's the next?
8.
Oh, wait, no.
400?
400.
So
yeah.
that'll be a little bit after, so I'll go down 40, so down here. Okay,
A little bit.
a little bit before that. Okay. And now I had a slope of negative 40. Now I am adding a slope of plus 40. So that's just going to make it a slope of 0 until I get to the next one. And then I had that slope of 40. So I'll have a slope of 40 until I get to my 6,000. And now I add a slope of negative 40 and I get 0. The last thing that this problem asks for is the damping factor. And so for the damping factor, what you do for that is you take your linear term from your quadratic pole or zero, which was 3.125 times 10 to the negative 4.
Oops.
And you set that equal to 2 zeta over the corner frequency of the quadratic term. So this was 2 zeta times the corner frequency of the quadratic term. And then you solve for zeta. So 3.125 times 10 to the negative 4 times 6401 equals 2 zeta. Or zeta equals 3.125 times 10 to the negative 4 times 6401 over 2, and somebody's going to have to do that. And by the way, your textbook uses a C instead of a zeta, but everybody else uses a zeta. And I talked to my Greek professor about it, and we figured that probably whoever wrote it just said it's the Greek letter with squiggles. And so
That sounds like an engineer right there.
yeah. And so it's usually a zeta. So
Either that or their work got so messy it turned into that.
well, that's a C. The C is really hard to write. The zeta is hard enough. But anyway. So I decided to use zeta. Okay, and that's the damping factor. And that's about all that I have in for today. But if I go home, I just keep checking the Moodle because I may add some videos later tonight.
Did you go over quality factor really quickly? It was the last thing we talked about.
Quality factors?
Yes.
I don't know quality factors.
Ah.
Then it
No,
must